In this video, we will learn about higher order derivatives. So remember that in the past, we learned that the derivative was the rate of change of a function. But what about now if we want to find the rate of change of the derivative? So that would be the rate of change of the rate of change. Let's see how that works. So if we have a function f, we can find its derivative, which is f prime of x, which is also a function. So we can ask again, okay, what is the derivative of this new function that we obtained? And that is how we will obtain the second derivative of a function. So the second derivative of a function, and we will denote this by f double prime, is defined as the derivative of the derivative. This means that f double prime is the derivative of f prime. If we're using the notation y equals f of x, then we can say that the derivative is dy divided dx. And so the second derivative will be written as d squared over dx squared. Let's try an example. So here we have f of x is equal x to the fourth plus 5x squared minus x plus 4. So let's try to find the second derivative. So remember, the second derivative is simply the derivative of the derivative. So we need to start by computing the derivative. So f prime of x will be equal to 4x cubed plus 10x minus 1. And now to find the second derivative, it's simply to find the derivative of this new function f prime of x. So remember, the second derivative is the derivative of the derivative, and this will be equal in this case to 12x squared plus 10. So we just checked that the second derivative is simply the derivative of the derivative. So now the question is, can we do this furthermore? Can we ask for the third derivative and the fourth derivative and so on? And the answer is yes. And this will be the definition of higher order derivatives. So once again, if we keep computing the derivatives of new derivatives, we will obtain higher order derivatives. So the third derivative will be denoted as f triple prime, but after 4 times this notation will become a bit messy, so we will use this new notation where the 4, 5 and 6 are between parentheses. If we're using the notation y equals f of x, then the higher order derivatives will be written as follows. So this will be the third order derivative. The fourth derivative will be like this. And so on. So now let's try this problem. Compute the first 5 derivatives of this function f of x. So let's give it a try. So the first derivative will be equal to 8x cubed minus 3x squared plus 10x minus 7. Let's go with the second derivative now. The second derivative will be 24x squared minus 6x plus 10 minus 0, right? So maybe we can erase this part. The third derivative will be equal to 48x minus 6. the fourth derivative, let's fix this, will be equal to 48. And we can see that the fifth derivative will be equal to 0. So just remember, computing higher order derivatives is simply computing the derivative of the previous derivatives. So we can do this as many times as we want, as long as we know how to compute derivatives.